Mr. Chairman, Board of Conference Committee, fellow presenters, ladies and gentlemen, I'm here to present the conference paper titled Investigation of Different Types of Distributed Generation Penetration on Radial Distribution Network, presented by NWEKE and Dr. NNADI. A paper presented at 2020 Sustainable Engineering and Industrial Technology Conference, Faculty of Engineering, University of Nigeria, Nsukka. Mr. Chairman, Board of Conference Committee, fellow presenters, ladies and gentlemen, I'm here to present a conference paper titled Investigation of Different Types of Distributed Generation Penetration on Radial Distribution Network, presented by NWEKE and Dr. NNADI. A paper presented at 2020 Sustainable Engineering and Industrial Technology Conference. Introduction. The impact of DG on distribution network is not only affected by the size and location of DG, but also affected by the types of DG. Here, there are three types of DG. Type 1 include solar PV, microturbine, and fuel cells. This type of DG is capable of injecting real power into the network. Number 2, that is type 2 type of DG. This type of DG is capable of injecting relative power into the network. They include synchronous fact compensators and diesel generators. Type 3. This type of DG supplies real power and in turn absorbs relative power. And the typical examples of this type of DG include wind turbine and induction generators. Methodology. 4 different studies have been carried out in this study using IEEE 30-bus radial feeder network. The study investigated these 4 issues. The base case, that is when the network is not installed with DG. 2. The impact of the different types of DG in the network when it is optimally located with optimal size. 3. The impact of power losses when these 3 different types of DG are placed within the network. And 4. Evaluating the voltage profile for each type of DG when placed at optimal position with optimal sizes. In order to obtain this objective, these steps of methodology are carried out. First, run the Newton-Raphson load flow analysis to evaluate the nature of the network based on power losses and the voltage profile. Step 2, evaluate the sensitivity index of each bus to know the bus that is capable of hosting DG. Based on these, form a priority list of DG placement for each of the bus that is capable of hosting the DG. Fourth, optimize the size of DG for those buses that have the capability to host the DG. After that, run the final Newton-Raphson load flow to obtain the active power loss, and then evaluate the voltage profile in each case of the different types of DG placed at optimum position. 4. Evaluate the simulation result for these three types of DG by comparing the losses and the voltage profile for each of these different types of DG. Simulation results and evaluation. Here is a display of the voltage profile result of the types of DG when placed at the network. Type 1, we use solar PV. At this point, we see the effect of solar PV when placed at the network, increasing or improving the voltage profile of the network from bus 15 to bus 30. There was much improvement. In the same way, type 2 use diesel generator. Here we have higher improvement in terms of the voltage profile compared to that of type 1. But in type 3, the voltage profile is least when compared to the first or type 1 and type 2 voltage profile of the network. Comparative result analysis of simulation results. There are 3 comparative results in this case: the voltage profile, power loss reduction, and DG impact on each bus. Here is the voltage profile. For the green is type 2, for the blue is type 1, and for the red is type 3, displaying different impacts on voltage profile of the network. In this case, type 2 and type 1 has a higher impact on voltage profile than that of type 3. In power loss reduction, here is the base case for type 1, base case for type 2, base case for type 3 power loss reduction. When DG is placed in each case for each type of DG, in the network, here is the reduction for type 1, reduction for type 2, reduction for type 3. But in all, comparatively, we can see that type 1 and type 2 has a greater power loss reduction compared to that of 3. The impacts on each bus is displayed here. You can see that this red type 1 DG impact on each bus has a higher impact or improvement in the network compared to overall conclusion. This study carried out an investigation on DG types and its impacts on distribution network using IEEE 30-bus feeder network as a case study. Equally, the study used photovoltaic DG as type 1, diesel generator as type 2 DG, and a wind turbine as type 3 DG. From the analysis, the study discovered that type 3 DG, that is wind turbine, has the least potential in real power loss reduction in the network, voltage profile improvement in network, and therefore this study concludes that it is a vital tool for system engineers on the choice of renewable energy resource selection in order to improve the distribution network. Thanks for listening.